Have you ever wondered if a computer could actually be creative? I don't mean just running calculations. I mean truly creating something new, something that's never existed before. Well, today we're going to pull back the curtain on the exact technology that makes this happen: Generative Adversarial Networks, or GANs. It's really just a brilliant game of cat and mouse that plays out inside a machine, so let's get into it. So let me just start by asking you a question. Can a computer create a face that doesn't exist? I mean, really look at these faces on your screen. What if I told you that maybe none of them are real people? Could a machine really just dream up a human face that's so convincing you literally couldn't tell the difference? Well, the answer is a huge, resounding yes. This person right here, they're not real. They never existed. This face was generated by an AI all the way back in 2017 using a generative adversarial network. And this isn't just a collage of different features. It's a machine learning how to create a totally unique image from scratch. And how it learns? That's where things get really cool. So how in the world does this AI magic trick work? Honestly, the best way to wrap your head around GANs is to think of them as a game, a really high-stakes creativity contest between two different AIs. Okay, so if we want to get a little more formal about it, a GAN is a type of deep learning model where you have two neural networks that are basically pitted against each other. They're locked in this competition, and the whole point, the grand prize, is to be able to generate new, super authentic data, whether it's images or music or whatever, that's totally indistinguishable from the real stuff. Let's just make this way simpler with an analogy. Mate are two players in this game. First, you've got the generator. Think of it as a master art forger. Its one and only job is to create fakes that are good enough to pass as the real deal. Then you have the discriminator, who is our brilliant art detective. Its entire mission is to spot those forgeries. And it's this constant battle of one-upmanship that really fuels the whole GAN process. Okay, so we've got our players, the forger and the detective. Now let's break down the rules of their game. How exactly does this little competition lead to those unbelievably realistic images we saw a minute ago? So it all happens in this endless loop. First, the generator starts with pure random noise, like TV static, and it tries to create its very first fake image. Then, that fake image is shown to the discriminator right next to a real image. The discriminator's job is simple. Is it real or is it fake? At the beginning, the fakes are awful, so it's an easy call. But here's the absolute magic. In step 4, the generator gets feedback. It learns why it got caught, and it uses that info to get better. This whole cycle repeats. We're talking millions of times, with both AIs getting smarter and smarter, until the generator's fakes are so perfect that the discriminator is basically just guessing. It's fooled about half the time. And at that point, congratulations, the game has created a master forger. All right, so this whole creativity game isn't just some clever academic experiment. It has some truly mind-blowing uses out in the real world. Let's take a look at what GANs are already up to. So one of the coolest things they can do is something called image-to-image translation. This is where a GAN can learn to turn one type of image into another. It can take a really simple sketch you drew and transform it into a photorealistic landscape. Or it can take a photo shot in broad daylight and make it look like it was taken at midnight. It's like having an impossibly smart photo editor who just gets it. Then there's another incredible use: super resolution. GANs can take a blurry, low-res image and intelligently fill in all the missing details to create a sharp, high-res version. And it's not just making the pixels bigger. The AI is literally hallucinating the details that it predicts should have been there. This is a total game changer for everything from enhancing medical scans to restoring priceless old photos. You know, GANs are also amazing at helping us train other AIs. See, sometimes you just don't have enough real-world data to train a model properly, especially in niche fields like medicine or science. A GAN can look at a small data set, learn all the patterns, and then generate thousands of brand new synthetic examples. This is called data augmentation, and it makes our other AI systems way more accurate and reliable. And the creativity here doesn't just stop at 2D images. By training on a ton of 2D pictures of an object, like a chair, from all these different angles, a GAN can actually learn to generate a completely new, fully realized 3D model of a chair that has never existed. This is huge for things like game design, architecture, and virtual reality. Now, as incredible as this all sounds, I have to be honest, training a GAN is notoriously tricky. That delicate balance between our forager and our detective, well, it's super fragile and can fall apart pretty easily. Yeah, researchers run into a few common headaches. One is called mode collapse. That's basically when the art forger gets lazy.
It finds one or two fakes that seem to fool the detective, and it just keeps making those over and over, so you get no variety. Another big one is vanishing gradients. This is when the detective gets too good, too fast. The feedback it gives the forger is basically just nope, fake, with no helpful hints. So the forger can't learn anything, and the whole training process just grinds to a halt.
You know, Ian Goodfellow, the guy who actually invented GANs, kind of summed up the problem perfectly. He said that in theory, this game should reach a perfect balance point, what's called a Nash equilibrium, where neither player can get any better. But in the real world, since we're using these super complex neural nets, the math that guarantees that perfect ending just doesn't apply. It makes training these things as much of an art as it is a science. And, of course, beyond all the technical stuff, there are some major ethical concerns here. The exact same technology that can generate a beautiful work of art can also be used to create deepfakes. We're talking about synthetic media that can create fake videos, make it look like people said things they never said, and be used to spread all sorts of misinformation. It's a really serious threat to our trust in what we see and hear. So even with all those challenges, the core ideas that GANs brought to the table have basically opened the floodgates for all of generative AI. This tech is absolutely here to stay, and it's evolving at a blistering pace. So where is this all headed? Well, as they say, just follow the money. The trend is crystal clear. According to Gartner, global spending on generative AI is just exploding. It's forecast to jump by over 76% in a single year. That kind of cash is fueling some absolutely incredible innovation. The next big thing is what's called multimodal AI. Right now, we kind of think about different AI models for text and different models for images. The future is a single AI system that can understand and generate content across all of these formats: text, video, audio, code, all in one seamless process. And as we look just a little further down the road, there are a few huge trends to watch. We're going to see the rise of autonomous agents, AIs that can handle complex, multi-step tasks all by themselves. We'll see more domain-specific models, which are AIs that are custom-built for industries like retail or law. And all of this is leading toward hyper-personalization, where basically every digital interaction you have is tailored specifically to you in real time. And that really brings us back to the big question. Generative adversarial networks gave machines this first little spark of creativity. But now, that spark is growing into a wildfire. As these systems truly master the art of generation, the power to create almost anything is going to be right at our fingertips. So the real question isn't what can the machines do, but what will we choose to create with it?